Hello everyone. Welcome to my channel. I am Balaji Chandrasekharan. Today, I will be discussing the comparison between the string, StringBuffer, and StringBuilder classes in Java. Java provides three classes to represent a sequence of characters: string, StringBuffer, and StringBuilder classes. We will be illustrating the comparison among string, StringBuffer, and StringBuilder classes. The string and StringBuffer classes were introduced since early Java 1.0. The StringBuilder class was introduced and in use since Java 1.5. Immutable class in Java means that once an object is created, we cannot change its content. In Java, all the wrapper classes like integer, boolean, byte, short and string are immutable. If required, we can create our own immutable class as well. The string class is immutable. The StringBuilder and StringBuffer classes are mutable and allows to change its content. Thread safety in Java is the process to make our program safe to use in multi-threaded environment. There are different ways through which we can make our program thread safe. Synchronization is the easiest and most widely used tool for thread safety in Java. The string class is non-synchronized, that is, not thread safe. It means two threads can call the methods of string simultaneously. The StringBuffer class is synchronized, that is thread safe. It means two threads can't call the methods of StringBuffer class simultaneously. The StringBuilder class is also non-synchronized, that is not thread safe. The string class performs very slow when we concatenate too many strings because every time it creates new instance. The StringBuffer class performs faster than the string class but less efficient compared to StringBuilder class when we concatenate too many strings. The StringBuilder class performs fast and more efficient to string and StringBuilder classes when we concatenate too many strings. The string class uses the string constant pool to store the string data. The StringBuffer and StringBuilder classes use the heap memory since they created object references of the StringBuffer and StringBuilder classes respectively. The string class consumes more memory when we concatenate too many strings because every time it creates new instance. The StringBuffer and StringBuilder classes consume less memory when we use them to concatenate too many strings. The string class overrides the equals method of object class. So you can compare the contents of two strings by equals method. The StringBuffer and StringBuilder classes don't override the equals method of object class. Both the classes use the default object class implementation of the equals method, meaning while comparison using the equals method, the comparison will check based on the object references since each and every new object instances are different. Now, we will understand the performance of string, StringBuffer, and StringBuilder classes with a small coding test. I am creating a new class named concat_performance_test in package com.balaji.java.basics. I check the main method stub so that it can be created automatically by Eclipse. Now, I am creating a new static method concat with string with a private modifier and with an input parameter n. I am declaring a new string variable with name value and initializing it with Java string value. I am writing a for loop starting from 0 to n. Within the for loop, I am concatenating the current string with a string value with Balaji and assign it back to the same variable value. Now, I am creating a new static method concat with StringBuffer with a private modifier and with an input parameter n. I am declaring a new StringBuffer variable with name value with an initial value as Java. I am writing a for loop starting from 0 to n. Within the for loop, I am concatenating the current string with a string value with Balaji using the append method. Here, the new value is concatenated in the same object instance. Now, I am copying the concat with StringBuffer method and rename it to concat with StringBuilder. Now changing the value variable data type to StringBuilder from StringBuffer. In the main method, I am declaring a new integer variable n and initialize it with 10,000. I want the for loops to be called 10,000 times to check the performance of each method. Getting the initial start time in milliseconds using the instant now and to epoch milli methods. Now, calling the concat with string method with n as input. Now logging the time taken for this method calling the println method. Like the same way, I am adding the code to call the concat with StringBuffer and concat with StringBuilder methods. I am executing the code now. You can see the time taken by using string class is very high compared to the other two classes. You can see that, there is not much difference in the time taken for the method calls done with StringBuffer and StringBuilder classes. Since string is already tested, I am commenting out the string test lines. Increasing the n value to 100,000. Executing the code now. You can see the time taken by using StringBuffer class is high compared to the StringBuilder class. Now, I am going to do the instance test. I am creating a new class named instance test. I am declaring a new string variable with name value and initializing it with Java string value. Now calling println method to print the hash code value of this value variable. I am concatenating the current string with a string value with Balaji and assign it back to the same variable value. Again calling println method to print the hash code value of this value variable. Running the code now. You can see that the hash code is different, which means that the string concatenation is creating a new instance of the string class. Now, changing the value variable data type to StringBuffer. Redefining the string concatenation using the append method. Running the code now. You can see that the hash code is the same, which means the new value is concatenated in the same object instance. Now, changing the value variable data type to StringBuilder. Here also, while running the code, you can see that the hash code is the same, which means the new value is concatenated in the same object instance. I have reached the conclusion of the session and look forward to seeing you in my next one. I hope you have enjoyed the video. Don't forget to like, share, and subscribe. Thank you for tuning in my video.